Alrighty, so with the only thing remaining as exams, well, I figure I'll do for our warm-ups here is I'm going to pick some of what I think were the toughest things we did all year and kind of just re-go over that kind of stuff. Obviously, there's examples of all these in the or the review as well, but I figure it might be good to just kind of touch on some of these big main concepts. So this was Unit 4, and this was doing all your different operations with fractions. These what we call rational operations. Multiplying, dividing, adding, subtracting. So this is essentially the same exact problem with just each of the operations, just so we can talk about what you need to do for each of these. So with multiplying, what we're going to want to do is simply get everything in factored form, and then we're going to look to see if we can eliminate or cancel anything out. So I usually do this as one big fraction. The top parts are already completely factored, so it's just x plus 3 and x. The bottom part, we have x plus 2. And then this can definitely be factored. So this is going to be, remember how this works, factors of 6 that add to 5, which we want to use 2 and 3. So this would be x plus 2, x plus 3. So once you get everything in completely factored form, it's all being multiplied, so that's why it's all just being multiplied together here. We take a look, and if there's any factors that are on the top and the bottom, we can eliminate those. And then whatever we're left with is simply going to be our simplified answer. So this would be an x on top, and then x plus 2 and x plus 2 on the bottom. A lot of times when you write that, just to make it as simplified as possible, you'd write it like this. But if you put the two x plus 2's by each other, that'd be equivalent also. So this would be our simplified answer. Now this also states to give any restrictions. So restrictions come from anything that was ever in the denominator. So in this case, x cannot be -2, and it cannot be -3. And again, the way I figure those out is I know I cannot have a 0 in my denominator, because if I have a 0 here, the 0 will multiply by all this, and we'll be dividing by 0, and we can't do that. It's an undefined value. So those are when it's talking about restrictions. That's what we're talking about, is zeros in your denominator. All right. For division, all we're going to do is change it to a multiplication problem by inverting the second fraction. So it's going to look identical to this, except for this part is going to be flipped. So the x plus 3 and the x plus 2 are going to stay exactly where they're at. And this is going to flip. So my x is going to go down to here. And this, if you remember, the factored form for this was x plus 2, x plus 3. And so at this point, all I do again is the exact same process as what I did up here. Multiplying and dividing are extremely similar because all you do is change your division to a multiplication problem by inverting and multiplying. So x plus 2's can cancel. We are now left with x plus 3 times x plus 3, so x plus 3 squared over x. So that'd be our simplified answer there. In this case, you have to look at anything that was ever in the denominator for the restrictions. So definitely -2. Both of the numbers from here, so that's going to be -2 again and -3. As well as this x, which is now in the denominator, so that would also be 0. So there are 3 restrictions in this case, because both of these are technically in the denominator of when you're dividing by that fraction. Okay, next ones, adding and subtracting. Adding and subtracting are very similar. For both, you need a common denominator. So if you remember, this factored to x plus 2 and x plus 3. So as of right now, these denominators are close to being common. They both have an x plus 2. This one just needs an x plus 3. So what I'm going to do in this case is multiply it by x plus 3 over x plus 3. Okay, so what that means is I'm going to have my denominator of x plus 3, x plus 2. And up here, I do need to distribute this out. And I'm going to write all of my things here being added in this case. So this is going to be x times x is x squared. I'm going to get a 3x and another 3x, so that's going to be 6x. And then I'm going to get a plus 9. Also, plus x. So as a whole there, that's x squared. Combine those like terms to give you a 7x plus 9. And then x plus 3, x plus 2. Okay, so at this point, we might be done, or we may have to go further. What we have to look at now is, can this be factored? So are there factors of 9 that add to 7? And there's not, because 1 and 9 would add to 10, 3 and 3 would add to 6. So this does not factor. Now, if you could factor this, you would want to, because maybe this factors to x plus 3 and x plus something else, and you can cancel out these x plus 3's and simplify it further. So in our case, nothing happens here, but definitely want to keep in mind that if you ever have a quadratic, you can factor it and look for things to cancel, just like what we had here. All right, and then restrictions. The denominator stays the same denominator the whole time, so it's just going to be can't be -3, can't be -2. So it's just like our first problem. All right, and then our last one, we've done most of the work for this already, right? So it's the only thing that's going to be different about this altogether is this is now being subtracted. So the only thing different is this is going to be a minus x. Everything else, though, is identical because it's the same exact process. Because you have to get the common denominator. You have to make sure once you have common denominator, you can take all these parts and you're going to subtract x from them. So at this point, what do we have? We have x squared. 6x minus x will be 5x now, and then plus 9 over the same exact denominator. And just like our last problem, we already know this doesn't factor because the factors of 9 are just 1 and 9 and 3 and 3, and neither of those add up to 5. So same restrictions, very, very similar problem. And this is how I always think of this stuff in my head is adding and subtracting have essentially the same exact rules. You get a common denominator, and then you add the numerators together. When you're multiplying and dividing, they're extremely similar. You factor everything and then see what you can eliminate. If it happens to be division, you invert it to turn it into a multiplication problem. And that's just kind of a good quick summary of a lot of Unit 4 right there.